Hello everyone, I'm Dr. NAVNEET KAUR, Associate Professor in Department of Electronics and Communication, SIRT College, Bhopal. Today I'm taking lecture of subject Digital Communication. The topic of my lecture is Binary Frequency Shift Keying System. In this lecture, I'll be discussing about the system BFSK system, which is Binary Frequency Shift Keying System. I'll discuss the generation and the receiver section of this system and also the signal space representation of the BFSK signals. Now first, what is BFSK or Binary Frequency Shift Keying System? In BFSK system, the frequency of the carrier signal is shifted according to the binary message symbol. The phase of the carrier and amplitude will be unaffected. Now, if the incoming message signal BT is 1, in that case, the frequency of the carrier will be increased by an amount, say, ohms. Whereas when the message signal is 0, the frequency of the carrier signal will be decreased by the same amount, ohms. So, for message 1, the frequency of the carrier will be high. That means the carrier will be transmitted at the higher frequency. Whereas when the message is 0, the carrier will be transmitted at the lower frequency. Now, say this is the message signal which is represented in the unipolar form, which is 1 and 0. Now we can represent this unipolar message in the form of the bipolar message, say dt. That means when the message is 1, dt will be represented as 1, whereas when the message is 0, dt will be given as -1 volt. Now here I am defining two more signals, PHT and PLT, which are again unipole representations of the message signal. PHT is 1 when the message is 1, whereas PHT is 0 when message is 0. Whereas PLT is complement of PHT. That means when message is 1, PLT is 0, whereas when message is 0, PLT is 1. Now, we can represent BFSK system equation in the generalized form as root 2ps cos 2 pi f naught plus dt ohm t. Now, when the message is 1, dt is 1. In that case, 2 pi f naught plus ohm will be the frequency of the carrier. Whereas when the message is 0, dt will be -1. So here we will have minus ohm. So here the carrier will be transmitted at 2 pi f naught minus ohms frequency. So this is the same representations as we have discussed in the previous equations. Now, here the higher frequency fh is represented by f naught plus ohm by 2 pi, and if I'll represent it by omega h, which is angular frequency, then it will be given as 2 pi f naught plus ohm. Whereas lower frequency fl is given by f naught minus ohm by 2 pi, and for omega l, I'll take it as 2 pi f naught minus ohms. Now, this is the block diagram for the transmission of the BFSK signal. Now, this is the input sequence. Now, we know that the BT is same as the PHT, whereas when BT is given to the inverter, we will get PLT. Now, if the message is 1, the value of the PHT will be 1, whereas when it is given to the inverter, it will be 0. So, value of PLT will be 0. Now, this lower loop will give the 0 output because PLT is 0. Now for upper loop, we will have level shifter. Level shifter will increase the amplitude of the PHT by root PSTB. Now here, since PLT is 0, the output of the level shifter will also be 0. Now here we have product modulator and we have carrier signal at higher frequency. So we can see that here we have carrier at 2 pi FHT. Now, when this will be multiplied by this carrier signal, we will get the output signal root 2ps cos 2 pi fht pht. Whereas since this is 0, the output of the lower loop will be 0. So here we will get the BFSK signal which will have the carrier which is transmitted at the higher frequency. That means when message is 1, the carrier will be transmitted at higher frequency. Whereas if the message is 0, in that case the upper loop will give the 0 output and we will get the lower loop as the carrier which will be transmitted at the lower frequency FL. Now, this is the waveform representation of the BFSK signal. Here we can see when message is 1, the carrier is transmitted at high frequency. Whereas for next TB, when message is 0, the carrier is transmitted at low frequency. Again, when the message is 1, the carrier is transmitted at high frequency, and whenever the message is 0, the carrier is transmitted at low frequency. Now, we can write BFSK signal according to the block diagram as root 2p pht cos 2 pi fht plus root 2p plt cos 2 pi flt. Now, we know that pht and plt cannot be 1 at the same time. Either pht will be 1 and plt will be 0, or plt will be 1 and pht will be 0. So, we will have either one equation whether the carrier will be transmitted at high or where carrier will be transmitted at low frequency depending on the message signal. Now, if I compare this with BPSK equation, it is BT root 2P cos 2 pi F naught T, where F naught is the frequency of the carrier signal. Now, comparing these two equations, there is one difference that BT is the bipolar signal. That means it is having value 1 and -1. Whereas PHT and PLT are unipolar signals. That means PHT is having value 1 and 0. Again, PLT is also having value 1 and 0. Now, if I want to change the equation of the BFSK signals as compared to BPSK signal, that means I want to convert PHT and PLT as bipolar signals. I will use two more representations of the signal PH-T and PL-T. These are two bipolar signals. That means they are having value 1 and -1. When PH-T will be 1, PHT will be 1. Whereas when PH-T will be -1, PHT will be 0. Same in the case of the second equation for PL-T and PLT. Now, substituting the value of PHT and PLT from equation given by this term, we will have root 2p, and here we have PHT substitution, and here we have PLT substitution. Now, expanding this, I'll get this equation. Now, here we can see that we have four terms. The first term represents the impulse which is at the frequency FH. The second term represents the impulse which is at frequency FL. Whereas third and fourth terms are similar to the BPSK equation because here PH-T and PL-T are bipolar signals. So last two terms will produce the spectrum which is same as that of BPSK spectrum. So here this spectrum will be located as at high frequency FHT, and this will represent the spectrum which is located at lower frequency FL. So here when we will see the spectrum of the BFSK signal, here we will have two spectrum. One is located at FL and one is located at FH, and one impulse is located at FL and one impulse is located at FH. Here, we will assume that the separation between FH and FL is 2FB because we want that there should be minimum interference between the two spectrums. So by taking the separation between FH and FL as 2FB, there will be minimum interference. That means whenever there is a maxima of first spectrum, there will be minima of second spectrum. And whenever there will be maxima of the second spectrum, there will be minima of the first spectrum. So here we can see that there will be two spectrums at FL and FH. Now, if we want to find out the bandwidth of the BFSK system, we will take the frequency range from this point to this point. Now we know that this range is FB. Again, this is FB, this is FB, this is FB. So FB plus FB plus FB plus FB will give the bandwidth as 4FB. So here we can see that the bandwidth of the BFSK signal is 4FB, whereas the bandwidth of the BPSK is only 2FB. So here we can see that the bandwidth of the BFSK signal is twice of the bandwidth of the BPSK signal, which is disadvantage of the BFSK system. Now, coming to the receiver section of the BFSK signal, here we will use synchronous detection method for detection. Now, this is the BFSK signal which is received at the receiver section. Now, this signal will be multiplied by the carriers, one at higher frequency and another at lower frequency. Now, if the message was 1, the carrier would have been transmitted at higher frequency. In that case, the output of this integrator and dump receiver will be high, whereas the output of this integrator and dump receiver will be low, because here the two frequencies FH and FL are orthogonal to each other. So for satisfying the equation of orthogonality, the product of the two carriers at FH and FL will be 0. So here S1T will be high, whereas S2T will be 0. So these two are subtracted and given to precision device. If S1T is high, the output will be positive, and in that case, the message detected will be 1. Whereas if the message would have been transmitted at low frequency, in that case, S2T will be high and S1T will be 0. So here we will have negative output, and in that case, the detected out message will be 0. So if the transmitted frequency is FH, the output is 1, and if the transmitted message is at frequency FL, the output is 0. Now, coming to the geometrical representation of the BFSK. Now, here we will assume that FH is some integer multiple of FB, same as FL. FL is also taken as integer multiple of FB. So here we will take two orthogonal carriers, one at frequency FH and one at frequency FL. So here we have taken FH as MFP and FL as NFP. So SHT will be root PSTB, and this is carrier, and SLT will be root PSTB root 2 by TB cos 2 pi FLT. Now substituting the value of phi1t and phi2t, we will get SHT as this and SLT as this equation, which is root PSTB phi2t. Now if I want to represent it on the signal space, I will have two orthogonal directions, phi1t and phi2t. So here we can see phi1t is given this in this direction and phi2t is taken orthogonal to phi1t. Now, as per the equation, SHT moves in the direction of phi1t with a distance of root PSTB, whereas SLT moves in the direction of phi2t with the distance of root PSTB. So here, this is SLT and this distance is root PSTB. This is SHT, which is in the direction of phi2t, and it is at a distance of root PSTB. Now, if I want to find out the distance between these two signals, so I will use Pythagoras theorem. Now, according to Pythagoras theorem, this distance will be root 2 PSTB, and PS into TB is given by EB, which is the energy of 1 bit. So this distance will be root 2 EB. Now, here we can see the calculated distance is T root 2 EB, which is given by the Pythagoras theorem. Now, as compared to the distance of BPSK, the distance in BPSK was root 4 EB. So here we can see that in BFSK, the distance between the two signal points is smaller as compared to BPSK. So in BFSK, the probability of error is greater as compared to the BPSK signal. Now this is all for today's lecture. Thank you.